In question 5, we are given a diagram below. Obviously, you have a cubic function there. How do you know that this is a cubic function? It's because the highest exponent is 3, right? However, you will notice that we are missing the coefficient of x squared, and we know that the y-intercept there will be -9, which is the constant. Let me just write that down because this is pretty much part of functions. So y-intercept, if you watch the first video that I did, you will know that the y-intercept is where the graph touches the y-axis, okay? Where the graph touches the y-axis, x is 0, and here y will be -9, okay? Now, how do I get that -9? I went to this function here, and everywhere there is x, I just substituted 0. It doesn't matter whether the coefficient of x here is 0 or not. I mean, that will give me 0. You'll have plus 3x. So where there is x again, I will substitute 0 over there. So that will also give me 0, and then I have -9. So that's why here f at 0 will be equal to -9, meaning that the x coordinate is 0 and the y coordinate is -9. So that is the point. Here we know that we don't know what x is, right? But what we know is that y is 0 because that is the x-intercept. This point, though, serves as the x-intercept as well as the turning point. We also know that the turning point, the y-coordinate of the turning point at that point will be 0, and we need to find the x value, which will be negative. Okay, x of a will just be negative. X of a will just be negative. And then x of b will be positive. All right, and then they told us that A and C are the turning points. So you know that, guys, when you find the coordinates of the turning point, you need to first find the first derivative, and then you will take the first derivative, equate it to 0. That is because the gradient of the tangent line on your turning point will be 0 because it'll just be a horizontal line on your turning point. Okay, then you solve for x. The x value that you solve after equating the first derivative to 0 will be the x coordinate of the turning point. You got that? And then obviously to find the y coordinate, you always go back to the original equation. You substitute the x value that you found into the original equation to determine the y coordinate of that corresponding x value. All right. So whenever you're dealing with functions and you need the y coordinate, you always substitute the x value into the original equation. Guys, you need to know what you're doing here. So we know that the first derivative will give us the gradient of the tangent line at a specific point. And if that point is a turning point, then the gradient of the tangent line at that point will be 0. That is why when we find the x coordinate of the turning point, we simply equate the first derivative to 0. Okay. Now, if you take the first derivative and you simply find the second derivative, when you find the second derivative, you have to use the first derivative. I will need to emphasize this. The second derivative is the derivative of the first derivative. I hope I'm making sense. You got that. The second derivative is the derivative of the first derivative. Does that make sense? Okay. Now, what you need to understand is that, remember I said to you, if the first derivative is equal to 0, then the x value that you find there will be the x coordinate of the turning point, right? However, listen to what I'm going to say. If you take the second derivative and equate it to 0, and then you solve for x, that x value will be what we call the point of inflection. So they already gave us that x value that we solved when we took the second derivative and equated it to 0. So the x value that we got at the point of inflection is negative 5 over 3, and y will be whatever. So to get our y value, we need to use the original equation and substitute that negative 5 over 3. But we can't get the y value because in the original equation, we have that monster there, which is p. Okay, let me see what the question says. The question wants us to calculate the coordinates of the turning point. Okay, there's a question that is missing here because this one is B. I need to include A. The question that I missed is actually A, which is this one here. So A requires us to find the value of P. I'm going to use the original function that we've got. They didn't give us any information here. The y-intercept will not help me calculate P. I don't have any x-intercept and there are corresponding y values. If I had one point that had a corresponding y value, it has the x value and the y value. It was going to be so easy. Now, let's say for this point of inflection there, they gave me y. I was just going to take the coordinates of that point and substitute them into the original equation and manipulate my formula to calculate p. But I can't do that. So all I've got is that point of inflection. And if you don't know how to get the point of inflection, you will have a problem. So what I'm going to do is to take the original function, which is f of x is equals to x cubed plus px squared plus 3x minus 9. I am going to find the first derivative. So 3 multiplied by 1 will give me 3. From 3, you minus 1. It'll give me an exponent of 2. And the second term will be 2 multiplied by p. That will give me 2p. And from that 2, you minus 1. So you'll be left with 1, which you do not need to write. And the third term will give me 1 multiplied by 3. That will give me plus 3. From that 1, you minus 1, and that will give you 0. So because it's 0, this whole x value will just be equal to 1. The derivative of a constant is equal to 0. So this is the first derivative, right? And what did I say the second derivative is? It is the derivative of the first derivative. So I'm going to take the first derivative and find the derivative. So the derivative of the first derivative, we call it the second derivative. You do the same thing. 2 multiplied by 3 will give me 6. From 2, you minus 1, you're left with 1. And here 1 multiplied by 2p will give me 2p. From that 1, you minus 1. So the exponent there will be 0. And x, the exponent of 0 is 1. So we don't need to write it. Okay, if I take the second derivative and I equate it to 0, and then I solve for x, which was given to us here, which is -5 all over 3. So if I was to take the first derivative and equate it to 0, it will give me that x value. All right, meaning that if I take that x value, which is the x value of the point of inflection, so let me just write it here, point of inflection. That is the x value of the point of inflection. If I substitute it into the second derivative, it should give me 0. So what I'm going to do is that I'm going to, where there is second derivative, I'm going to substitute 0. And where there is x, I will substitute at -5 all over 3. And then I'll have plus 2p. And then you just solve for p. 6 divided by 3 will give me 2. So I'll have 2 times -5 plus 2p. That'll give me -10. Okay. So I will end up having 0 is equals to -10 plus 2p. Transpose 10 to the other side, it will be positive. I'll be left with 2p, and then you divide both sides by 2. And 10 divided by 2 will give you 5, so p is equals to 5. Okay? I hope it made sense. Did you enjoy it? Was it great? I'm glad if you did. So that is the value of P. And I obviously looked at this one here. It says if P is equals to 5. So that is confirming what P should be. For P, please be on the lookout for the next video. See you in a moment.